Today we're working on section 2.7. Our objective is to graph linear inequalities and absolute value inequalities. Our warm-ups are not on your paper. We are just going to discuss them. If you would like to make little notes in the margins to review, you may. Can someone raise their hand and tell me what slope-intercept form for a linear equation is? Charles. Y equals mx plus b is correct. Somebody else raise their hand and tell me what point slope form for a linear equation is. You want to give it a try? Devin?
Y minus y1.
Good.
Equals. It's like some parentheses x might say one.
Okay. What do you think goes in front of those parentheses? Caden?
M.
M. Very good. All right, finally, we need to know what standard form for a linear equation is. That's the one that looks different from the other two. It does not involve an M.
Ax plus by equals c.
Very good. Ax plus by equals c. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane that is bounded by a line. In order to graph, you will graph the boundary line. That line will be solid if we're using a less than or equal to or greater than or equal to symbol. Or the line will be dashed if we have just a plain less than or plain greater than symbol. So if it has the equal to bar, it's a solid line. If it does not have the equal to bar, it's a dashed line. Finally, we will shade the side with the solutions. So we'll test a point. If it works, we shade that side. If not, we shade the opposite side. All of this will make a little bit more sense once we're able to do some examples. Let's do some examples. Our first one, y is less than 1/2 x minus 3. When we graph our boundary line, we are going to graph it as if it were an equal to bar, equal to symbol here. So we treat it like it's y equals 1/2 x minus 3. So if we were graphing y equals 1/2 x minus 3, who can tell me where I would start my graph? Jacob?
Negative 3 on the x axis.
Negative 3 on which axis? The x-axis or the y-axis? The y-axis. Okay, so our y-intercept is negative 3. So we go to negative 3 on the y-axis. We put a point. From that point, where do we go? Izzy?
Up 1 to the right 2.
Up 1 to the right 2. Our slope is 1/2. So from that point, we go up 1, right 2, up 1, right 2. And we can keep doing that. Now, these ones, I'm going to make more points because I don't think I have an option to make a dashed line. Up 1, right 2. On these ones, it's going to be extra important that you go through the entire graph, because we're going to end up shading. Okay, so based on what we said on the front page, when I draw a line in here, is it going to be a solid line or a dashed line?
Dash.
How do we know?
It doesn't
Very good. There's no equal to bar on this inequality symbol, so I need my line to be dashed. So, dash this line. Again, you can just put a straight edge on it and then just dash every now and then. The dashes don't have to be perfectly spaced, but I should be able to tell that it is a dashed line. We should still have arrows at either end, and it should go the whole way through the graph. So I recommend plugging in 0, 0. That means I plug 0 into y, and I plug 0 into x, and I want to know if this comes out to be a true statement or not. So then I just start simplifying. Leave the left side alone, just simplify the right side. 1/2 times 0. 0 minus 3. Okay, so then my statement comes out to read 0 is less than -3. Is that true? No. So that means that 0, 0 is not part of the solution set. So I do not shade that side. And go to the opposite side of my boundary line, or the other side. And I shade in that whole side. So take your pencil, you shade in that whole side of that line. Now, I try not to get terribly picky with shading. It doesn't have to be shaded in like solid black. You don't have to be that, it can just be scribbled in. However, what I should not see is that you did this. Okay, that does not tell me that you shaded it in. Also, some people think that the axes act as boundaries, and so some people would only shade right there. That's also not correct. Our only bound is this dashed line, so I should see everything in that area getting some shading. It doesn't have to be pretty, but it should be obvious where you're shading. I shouldn't have to wonder what it was you were thinking. All right, on to number 2. Number 2, our inequality is y is greater than or equal to 3x. Can somebody new raise their hand and tell me where they think I should start this graph? Emily? Are we adding or subtracting anything on the end here? No, so 0. So our y-intercept is 0 because that's what our b would be if we think about it as y equals mx plus b. And then what is our slope? Logan? 3 over 1, which means I should go where? Up 3 over which way? To the right. Very good. So we go up 3, right 1. Again, I'm going to keep making more points so that I make sure I go through my whole graph. Many points as possible. Remember, if you switch your order, so instead of going up and to the right, we can go down and to the left, it'll still be on the same line. So that's how I'm getting points to go all the way through my graph. And then when I graph this line, should it be solid or dashed?
Solid.
Because it has the equal to bar. If it has the equal to bar, you want a solid line. There's my line. I'll put arrows at either end. All right, we've graphed our boundary line. That's half the battle. The next half is figuring out where we are going to shade. Can I use 0, 0 as a test point this time? No, it is on the line. If it's on the line, I can't use it. So sad. Who would like to raise their hand and suggest a different point? Lanaya. 1, negative 1? Okay. It doesn't matter to me. As long as the point's not on the line, we can use it. So we're going to test 1, negative 1. That's that point right there. So I just mark it so I know where I'm looking at. I plug what in for y? Negative 1. Greater than or equal to 3 times 1. 3 times 1? So I'm left with negative 1 is greater than or equal to 3. No, that's not true. So I do not want to shade on the side where I put that little x. I do not shade that side. I go to the other side of my boundary line, and that's where I shade. And again, we shade in the whole thing.
How do you know which side would like shade on? It's like that.
So we test a point. If that point works and makes a true statement, we would want to shade where that point is. If that point does not work, we go to the other side.
Okay, and can you zero it?
All right, let's go for example 3. Example 3, 4x plus 2y is less than 4. Just so that we can get a refresher on other options. Okay, because I notice that this is in standard form, and I know that both 4 and 2 can divide into C, this other 4, I'm going to graph it using my intercepts. Alright, so I'm going to graph with x and y intercepts. In order to do that, I'm going to plug 0 in for y and solve for x. So for x, what is 2 times 0? 0. So I've got 4x. I'm just going to treat it with an equal sign because I'm solving for an intercept, so it's okay to change it to an equal sign. What is x going to equal? 1. So I go on my x-axis and I put a point at 1. Now to solve for y, I'm going to plug 0 in for x and solve for y. 4 times 0 is 0, so I'm left with 2y equals 4. So y would equal 2. So I go to my y-axis and I plot a point at 2. We want a dashed line because there's not an equal to bar. So let's see. I'm going to do mine a little differently this time. So one way of doing it would be to insert a solid line and then erase little chunks of it, right? It's not very pretty on here, but it's an option. Also, if you're using pencil, it's another option. Just make it solid and then erase chunks of it, but don't write so hard that when you erase it, I can't tell, right? Okay, so Caden was asking about our test point. We can use 0, 0 because it is not on the line that we graphed. So I like that idea. What is 4 times 0? 0. What is 2 times 0? So we end up with 0 plus 0 is less than 4. What is 0 plus 0?
0.
Still 0. Is 0 less than 4?
Yes.
Yes, it is. So therefore, we are going to shade where 0, 0 is. So we shade this whole side. Whole thing. All the way up until our line. Top to bottom, whole thing. I guess I could use something bigger to shade that looks a little better than the scribbles. Questions about graphing our boundary line, picking a test point, rearranging the equation? When you do use a test point, so we used 0, 0, if you want to plug it into your transformed equation, You can.
I got the wrong answer though.
Oh, see, that's what the issue is. So I would always plug it back into the original. If we plugged it into the transformed equation, you should have gotten 0 is less than 2, which is still true.
Oh yeah, true.
Okay, so it still should work, but I always prefer to go back to the original. Kind of personal preference.
But you still get the right answer if you go back to it.
Yeah, it should work out the same regardless of if you use the original or the transformed. It should, if you did everything else right. Okay, let's go on to number 4. I'm going to give you a couple moments to do this one on your own, and then we'll talk about it. Okay, let's go through that one more time. So I agree with using our y-intercept at 1, and then using our slope to find more points. Up 3 over 2. All my points should be on the line, right? Or down 3, left 2, still my points should be on the line. Oh good, they are. Must mean we got a really straight line here. Okay. Alright, then we put our solid line in because we've got the equal to bar. Solid line, I like it. We put our arrows on both ends like wonderful students would. We used a test point of 0, 0. So 0 went in for x and y. We end up with 0 is greater than or equal to 1. Whoever did our shading decided that that was false, and I agree. 0, 0 does not work, so we should not shade there. We should go to the other side of the line, and that is the area where we should shade it in.
Is there a time that could I get a Band-Aid?
Okay, so we have successfully graphed a few different linear inequalities. Now, time to go on to absolute value inequalities. All right, for absolute value inequalities, we are going to graph the inequality as previously learned. So basically we're doing the same thing, graphing a boundary line. And then we have to decide if we are going to shade inside or outside of the V. So this is very similar to what we were doing just now, but it's with absolute values instead. Here we go. Let's do some examples. First one, we have y is less than or equal to the absolute value of x minus 4 plus 5. When we graph these, again, it is important to identify your vertex first. So in order to identify our vertex, we always talked about our M, our B, and our C. What is our M? 1. It's whatever's right in front of X. That would be a 1. Our B is -4. And our C? All right. To find our vertex or identify our vertex, we use the opposite of B over M, comma, C. That is something you should have known yesterday. It's something you're going to have to continue to know. +4 over 1. 4 over 1 is really just 4. Okay, so the opposite of B would be +4 over 1 is 4, comma, C is 5. That's where my vertex goes. 4, 5. Let me see if I can get this on here. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. There's our vertex. Now we have to know, is this going to open up or down? Up. Our V opens up because it is positive in front of the absolute value bars. So we can use our slope to get more points. What's our slope? 1 over 1. You can use an XY table if you'd like. To me, using slope is quicker, but you have to then use your symmetry. We go up 1 over 1, up 1 over 1. But that's only half of our V. To get the other half, we go back to our vertex and we go up one, left one, up one, left one, up one, left one. Okay, we have to get a V that is symmetric. Okay, so if your V is itty bitty, that's okay. You just got to work with the graph you have. When I go to make my V, is it going to be a solid line V or a dashed line? Solid line, because we've got the equal to bar. So we've got solid line going this way, and then our other solid line coming out this way. Again, if you want to extend yours past your graph to get a little bit bigger V, that's fine. Then we have to decide where to shade. So in order to decide where to shade, we pick a test point. 0, 0 is not on our V line, so we can use that as a test point. So I'm going to erase all of my vertex stuff so that I've got room to show my test point. So I'm testing 0, 0. I'll put a little X there to remind myself of that. 0 is less than or equal to the absolute value of 0 minus 4 plus 5. 0 minus 4. The absolute value of negative 4. 4 plus 5. 0 is less than or equal to 9. That's true, right? 0 is less than 9. So that means, are we shading inside of our V or outside our V? Outside. We've got a lot of stuff to shade. So again, it doesn't have to be shaded in like solid black or gray with your pencil, whatever. Just shaded so that I know you are shaded outside of the V.
Who made these?
We have y is less than the negative absolute value of x plus 1 plus 3. Again, I think it's important to identify our vertex first. To do that, I need to know what M, B, and C are.
1, 1, 3.
Yes, our slope, or M, is 1. That's what's right in front of the x. Remember, we don't consider this negative out in front of the absolute value as having anything to do with the M right now. What does that negative sign mean?
Well, everything is negative outside of that. Or whatever.
Sort of. Whatever we get in the absolute value, it's going to be negative, but what people were saying about our graph is that it will be upside down. Okay, that's what that negative sign is important for. B is also 1, C is 3. So for our vertex, we take the opposite of B over M. Negative 1. Negative 1 over 1 would be negative 1, comma, C is 3. So we graph that point. Negative 1, 3. V is going to open down, and we are going to use our slope. What's our slope? 1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Right? You can keep on going and going. But we have to keep it symmetric, so we're also going to go down 1, left 1, down 1, left 1, down 1, left 1. And of course you can keep on going. Are the lines going to be solid or dashed? Dashed because it's not equal. So I'm going to put mine in as solid lines, and then I'm going to go back and turn them into dashed lines. Remember, we go all the way through our graph. Let me turn these. Ooh, that's too much. Still too much. That's better. Just make it dashed. Okay, we have a dashed line. Looks beautiful. Then we have to decide where to shade. How are we going to decide?
0, 0.
Pick a test point. I like 0, 0. So we plug in 0 for y.
We use like negative on the outside. Doesn't matter. Like on the outside of the absolute value of bars.
So I am going to use it, yes. Yes, we plug in x and y to our original problem. So 0 less than, what is 0 plus 1? The absolute value of 1. Well, it's a little weird here, right? So the absolute value of 1 is 1, but then we're making it negative. Negative 1 plus 3 is 0 less than 2. Yes. So are we shading inside or outside? Inside, because that's where the 0, 0 was, and it worked. So we are shading everything inside of the V. Okay. As you're working on this, hopefully you got to your vertex already. It's at 0, negative 3. So I'll go ahead and plot that. What's your slope? 2 over 1. And is it opening up or down? All right. Because our m is 2. So I turn it into a fraction, 2 over 1.
So up 2 over 1.
Yep. And we can do that both ways to get a symmetric V. Will my lines be solid or dashed?
Dash.
Ooh.
Solid. They're dash.
Solid.
Why are they solid?
Oh, I didn't see that. Sorry.
It's okay. So we've got an equal to bar. That makes it solid. All right. Then we have to decide if we're shading inside or outside. Some people are saying outside. Some people are saying inside. Well, let's test a point. What point should we test?
0.
Okay. If I plug in 0 for x and for y. 2 times 0.
0.
The absolute value of 0. 0 minus 3.
Negative 3.
Is 0 greater than or equal to negative 3? Yes. If this is true, 0 is greater than or equal to negative 3.
Oh, shit, I'm tripping.
Positive 3. My bad.
We are going to shade where that point is. That point is inside. So we are shading inside. All right.